solar batteries in parallel connection. Solar batteries in parallel connection. In series, we saw how we connect them in series connection, okay? Now today we're going to see how we connect these batteries, the solar batteries, in parallel connection, okay? You're welcome. And have you ever known or have you ever wondered why people increase the capacity of their solar system without changing the solar voltages? Have you ever wondered why? People change their capacity or increase the capacity of their power banks without changing the voltage. Okay, and this is where the parallel connection comes in, and we are going to see how it comes. Which magic does it come to use to increase the capacity, the energy capacity of the power bank, and you leave the voltages constant, and this is the parallel connection. Let us see here. I have shown you one battery, another battery. We have two batteries. We are going to connect them in parallel, okay? As we said, as you remember on our topics on the solar panels, we talked about series, parallel. Also, we talked about series parallel connections. Now, the same principle that in parallel connection, we increase what? The capacity in batteries. We increase the capacity, in parallel. Capacity is the AH, okay? But the voltage will remain the same, okay? That is the parallel connection. Whereas in series connection, the voltage increases and the AH or the capacity remain constant. That is in series connection. Whereas in parallel connection, which we are looking at today, is the voltages remain constant and the capacity of the battery, which is the ampere hours, increases. That is the parallel connection, as you are going to see. Now, let us try to connect our batteries into parallel connection, okay? We said in parallel connection, all terminals, positive terminals, there are two terminals, okay? We have positive terminal, which is this one. We have negative terminal, okay? Now, in parallel connection, all positive terminals goes on positive terminal. This is another battery. It has a positive terminal. Now, all this positive terminal will be connected on this positive terminal. Even though you're connecting an inverter, you connect on a positive terminal, okay? Whether you're connecting your bulb, you connect in positive terminal, and a negative terminal will go on negative. Don't interchange. In parallel connection, we don't mix like in series. Series we said positive, negative, positive, negative. That is connection in series. But in parallel, we connect a negative terminal. All negative terminals are connected on one terminal. Because if you have your TV, this is your TV, it has two terminals, a positive and, and a negative, okay? When you're connecting these, you connect the negative terminal, it goes up to negative on negative. Then positive will also go on a positive. That is what I was meaning, that even a TV, when you're connecting it, connect it, a positive cable, connect it on a positive of the battery. Even though you're connecting an refrigerator, all connections on positive goes on positive. All connections on negative goes on negative. That is the parallel connection. I was just showing you a bit of connecting the parallel connection. Now let us try to connect our battery. Okay? Let me hope we are together, because our aim when you're connecting the the parallel connection, we are increasing the capacity, the energy capacity of the battery. And why we do like this helps us to run for a long time. Our battery capacity will run for long time. Let us say our inverter uses 12 volts. Okay? And we want to make this capacity or our TV show for long hours, or the lights. Okay? If you want your light to light for longer hours, you will add, we need to add the capacity. The capacity is the ampere hour. Okay? Meaning we must connect batteries in parallel so that the capacity adds on. But the voltages, remember it is 12 volts as we said. If our inverter uses 12 volts, the voltages will remain constant 12. Even though you add 5 batteries in parallel, the voltage will remain 12 volts. But the capacity, the AH, the ampere hour, will increase. Okay? Let us try to connect these batteries in parallel. Let us see that, as we have said, all terminals, either positive or negative. We connect positive terminal on positive terminal, a negative terminal on negative terminals. It goes like that. Now check. This is positive terminal. Let us connect it on positive terminal. Positive terminal with a positive terminal. Okay? Now, we need to connect also a negative terminal for this battery 1 with a negative terminal for this battery 2. That is the parallel connection. Like this. It comes, we connect. Okay. Now, we have negative terminal of one battery. The first battery is connected on a negative terminal on the second battery. Okay? And here, positive terminal, we have connected it on a positive terminal on the second battery. And this is the parallel connection. Even though we have another battery, let us see how we connect another battery. If you have another battery like this, okay, let's assume this is our battery, positive terminal, a negative terminal. We can also add another battery. It depends how many batteries you can have in parallel connection. We can also add this. If this battery was 12 volts, 100 ampere hours, even this one 12 volts, 100 ampere hours, okay? Even this one, still always connect them when they are having the same values, okay? 100 ampere hours. Always use same values, don't interchange values. If this is 100 ampere hours, do not put here a 70 ampere hours and then you put 100 ampere hours. That is wrong. Okay? If you want your system to be perfect, use the same values, the same value, 12 volts, 100 ampere hours. Now we want to connect this battery with these ones in parallel. We said in parallel, all positive terminals are connected together, meaning this point is the same as here, this point is the same as here. Now we connect from here, we come. You see, positive, positive, positive are put on one terminal. These are cable just looping to the positive terminals. We need to connect also the negative terminals so that we make it a parallel connection. Here you come like this, you connect your cable. This is a cable, okay? Negative, negative, negative on one thing. They are connected together. Positive, 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 connected together. Okay, and this is a parallel connection. Now, tell me, what is the value, the total value? Okay, let us get here. This is the terminal for negative or positive, and the terminal for negative. This is negative. Now, if you get your multimeter, okay, you get your multimeter, you want to measure here. Always double check your terminals. If you're connected, well, double check, please. Never rush to connect this. Always think about the connection. Okay, you know me, the way I did it to master the things. Once you think about in electrical or in technical work, in engineering work, me, the way the principle I use, don't do what you don't know. Never do anything you don't know. Okay? Don't wire anything you don't know. The first thing you need to know, once you are doing the parallel connection, either series connection, always first think about it. Okay? If you're dealing with parallel connection, what are your aims? What are your goals? You're looking for more capacity in parallel. Yet in series, you're looking for more voltages. Okay? Now here we need 12 volts. Okay? But we need more capacity so that our machines or our appliances will run for longer hours. Okay? Parallel connection increases the capacity of the energy stored and makes our system to run for longer hours. Okay? Now, here we have 12 volts, 100 ampere hours, 12 volts, 100 ampere hours, 12 volts, 100 ampere hours. Okay? Now, we want to measure what is the total energy stored in this power bank. The total energy, remember we said in parallel connection, the capacity, the energy stored increases in parallel connection, but the voltages remain constant, don't change. If it is 12 connection, it remains 12 connection. Meaning, if here we have 12, we have 12, we have 12, in parallel, still we shall have 12 volts. We shall have the total here, we shall have 12 volts. I don't know if you're seeing this, 12 volts. Now, we have said 12 volts, 12 volts, 12 volts. We have not added so that it becomes 12 for 24, 36. No, it is 12, 12, 12. But if you are in series connection, these voltages will add on 12, 24, 36. Okay? Now we are in parallel connection. This voltage will remain constant. 12, 12, 12, constant. Now, the capacitance of the batteries will increase. Okay? How does it increase? We get this 100 ampere hour plus this 100 ampere hour, those are 200 ampere hours, plus this 100 ampere hours, that is 300 ampere hours. Here our power bank will be with 300 ampere hours. This is 300 ampere hours. Whereby in series connection, the voltage increases, the voltage will become 24, 12, 24, 36. Then the capacity will not increase. The capacity will remain constant in series connection. Not the difference. Series connection and parallel connection. In series connection, the voltages increases, but the capacity remain constant. But in parallel connection, the capacity increases, but the voltages remain constant. That's how we have found out this 100 plus this 100 AH plus this 100 AH in parallel, they add up to make 300 AH. and we are having a 12 volts, 300 ampere hours, whereby you will get your multimeter. This is your multimeter. After getting your multimeter, test here on the last terminal. Okay, even though you test here, it will give you this. This point is the same as this point, is the same as this point, is the same as here. Okay, if you measure here, it is the same as measuring here. This one is the same here, because if I rub here, it comes this point. You see the logic behind. Now, if you measure here with your multimeter, this terminal, or you measure here, if you measure this terminal and this terminal, it is the same as measuring here and here. It is the same as measuring here and here. It will give you the same voltages. Now, if you measure here and here, positive and negative on your multimeter, it must give you or indicate 12 volts. Okay? If it indicates any value, please recheck the connection. You may have done some series connection, yet you are dealing with the parallel connection. In parallel, our focus is maintaining the voltages, maintaining the capacity. We want the capacity to go high or much, so that our appliances will work for longer hours, and these batteries will not need recharging very fast, because it has big capacity or ampere hours. Okay, it will take long to get discharged because of the capacity being big for our appliances to run for more hours. Hours, we are dealing with current and hours. Ampere hours, we are dealing with hours. When you add the capacity, it adds this and this one, we get the 300. This is 100 AH, that is 300 ampere hours. We are dealing with hours, meaning we have added more hours, meaning more hours will be given to our appliances. Okay, and they will run for more hours before the battery will need to be recharged. Okay, that's the best thing for the series connection. Series connection is very good. Okay, now after seeing the series connection, and we have seen that it helps to increase the capacity, the energy capacity of our power bank, and it is used, the voltages remain constant in case you're having an inverter which uses 12 volts. All this parallel connection is very good for that inverter, because you will be having longer hours to use your power bank, and the inverter being a 12 volt inverter, it means your battery bank, your appliances will be powered with power for longer hours. Okay, yeah. Now I'm going to show you some of the mistakes you need to avoid when you're dealing with parallel connection. Okay, it has also some mistakes as a technician you need to know in mind before you do the parallel connection, and I'm going to show you, and I will show you the tips, and I show you how when you're handling with parallel connection, because in parallel connection we are dealing with current. Ampere hours is increasing, meaning amperes, those are currents. You know, when currents come, when current is big, or when the amount of the quality or the quantity of the current is big, meaning you may experience shocks. Okay, electric shocks, because these electric shocks come with the result of high currents. Now here in parallel connection, we are dealing with high currents. The voltages are constant, but currents are increasing, meaning we shall deal with some protective gears when you are dealing with the parallel connection. Okay, but let us see, we are going to see the mistakes which are done, which you need to avoid when you're dealing with these high currents, okay, or high capacity stored. The capacity, I mean the AH, the ampere hours. Okay, now then, let us jump into the mistakes to avoid when you're dealing with a parallel connection. Okay? Okay, now, as we have seen the connection of the parallel connection, battery 1, battery 2, battery 3, and the capacity has increased. Now, let us see some of the mistakes you need to avoid as a technician before you master or before you put down your battery connection. You need to have this, or you need to avoid this in your connection. When you're doing the connection, please, in parallel connection, it is so dangerous connection because we are dealing with currents. The capacity increases. That is, AH increases. The AH, the ampere hours, increases, meaning you're dealing with much currents, okay? These currents are dangerous. If you mishandle them, you may have some electric shocks, okay? Then in series, there is high voltages, okay? Also, voltages are dangerous. Now here we're dealing with high currents, okay? Now, one of the mistakes you need to avoid in your installation, whenever you are doing any solar installations, avoid these things. One, mixing. Do not mix different battery types. What I mean, do not mix different battery types. Do not mix different battery types. These are one of the mistakes to avoid. Avoid mixing battery types. What I mean is mixing this or brands, types the same as brand. Okay, like this brand is a lithium or type, a lithium battery. Then you again put in parallel with a lead acid battery. Then again you put a lithium battery. That is wrong. Do always use the same type or the same brands. If this is a lithium battery brand, use also lithium. Also use lithium. If you're using a GM, use GM, okay? And this system, when they have the same brands, they will work properly, because we don't know if you mix a lead acid battery and a lithium ion battery. We don't know the manufacturers, what they did on their battery cells. You know, in battery there is cells inside. Now, you will interfere the connection of the flow of electrons inside the cell. Like the lead acid battery deal with acid, and lithium ion batteries are powdered. So it interferes the reaction, the chemical reaction of the electrons. Okay? Now it is not advisable. Please avoid it. Do not mix brands when connecting in parallel. Even though in series, don't mix brand. Buy the same brand. If it is lithium, use lithium, and your system will work well. The second point we are saying, don't mix old and new batteries. Okay? Do not mix old batteries and new batteries. It will not work well the way you want it, because when this battery is new and this battery 2 is old, and this battery 3 is new, the system will not work the way we want it. The efficiency will lower down. The amount of bringing power to the appliances will go down. Okay? Meaning, if you're using the new installation, please use new batteries. New battery. Don't mix that you're saving some money and you buy one old battery, then you mix with other new batteries. No, the system will not work the way we want it, or the way we have calculated it well. Okay? Now use new. Don't mix old batteries and new batteries. Avoid it. Technically, avoid it. It's not allowed in solar installations. Now let us see the third point is, don't mix different capacity. Do not mix different capacity. Do not mix different capacity. What do I mean? Mixing capacity, remember you are dealing with capacity in parallel. Okay, capacity is the ampere hour. Okay, the ampere hour is 100 ampere hour. If this is 12 volts, 100 ampere hour. This is 12 volts, 100 ampere hour. 12 volts, 100 ampere hour. This is the proper arrangement in connecting in parallel. Now, don't mix the capacity. Capacity is the ampere hour. Here you put 100 ampere hour, and then you go on and put a 200 ampere hour. No, not allowed. That's a mistake. Again, you go and put a 100 ampere hour. You see, you're mixing the capacities. 100 ampere hour, 200 ampere hour, 100 ampere hour. That is mixing the capacity. Whereby our point is saying, don't mix different capacities. Meaning, don't make these capacities. Always use the same capacity according to your calculation. Okay? Even though you're connecting them in parallel, don't mix. Don't say that since it is connected in parallel, it is. Remember, when you mix a 100 capacity or 100 AH and a 200 AH, your system will focus on 100 AH only and leave the 200. Meaning, your 200, you are wasting your 200 AH battery for nothing. And if your 100 AH gets over, the system will shut. The 200 will not work. That's why it is good to use the same value, the same capacity, the same ampere hours. If it's 12 volts, let it be 12 volts, 100 ampere hours. Let this be 12 volts, 100 ampere hours. And this 12 volts, 100 ampere hours. Do not mix the ampere hours, okay? It will affect your system and your calculation will be not really. Those system comes when you are just guessing for any battery you are putting without doing the calculation which we did. Okay, that's why I always tell you, go back and see the calculation so that we follow the system regulations or the system procedures in solar. Let's see another point. We are seeing here another point. Don't mix different cable size. Do not mix different cable size. What do they mean? Mixing different cable size. Remember, you're dealing with current, capacity, ampere hours. That is current. Now you're mixing cable size. Current means to be respected. Current is a crucial thing in electrical. Okay, you need to respect this part, the current thing. Okay, you know there is current, resistance, and voltages. Now, voltage is the pressure which pushes the current. When our pressure, the voltage is 12, that pressure which pushes the current to flow. And we're having our current 100 AH. In 100 there is current and the time to be taken. That is, it comes to be our energy. Okay, our energy stored is 100 AH. Okay, now if you're changing the cable, as our point is, do not mix the different cable sizes. If this cable from this battery 1 is 2.5, again it reaches on battery 2, you use 1.5. You see, this one is carrying much current coming. Now reaching here, this current, also this battery will bring current. Now, the current, some current may go into this because of the small cable, or the current from this battery may not pass. You know, when something is big, the small thing, let us say when a car is moving on this road, straight road, another car comes and they collide. Which car gets more damaged? A small car which is coming and collides with a big car which is moving straight. Now it comes here. This is small current. You have used 1.5 here, and here you have used either 3 millimeter or 4 millimeter. Now 4 millimeter is carrying big current. it is bringing it here to our point here. Now this 1.5 millimeter of a cable, this one, is bringing small current. Now this current will not allow this small current to enter, okay? And we shall end up not using this battery. You see the logic of mixing the cable size. Our point is, don't mix the cable sizes. Always use the same cable sizes, okay? Always use the same cable sizes so that it carries the same amount. The same amount which comes from battery 1 will be the same amount which comes from battery 2, and will be the same amount which comes from battery 3, and they will collide together and they will go at once, okay? Now the battery with small cable will not be used because of the small current which is being coming. And remember, there is some resistance. Now this big current which is passing will act as a resistance to the small current, and the small current will not flow the way we want it, okay? Now another point, now this is always use fuse protection. Always use, always. This is not avoid. It means always. I mean always use fuse for protection. Since we are dealing with current or capacitance, okay? The capacitance stored, that is AH, ampere, which is current, and H is the time taken, that is hour. Now we are dealing with the current. Always to avoid shocks or electric shocks, okay, or burn. You know, in solar, DC doesn't shock unless when you're using the inverter, which turns DC into AC, okay? Now on DC, a battery just burns. The battery can burn you because of high current. A battery burns, but it doesn't shock. But electricity shocks and it burns, okay? But for solar DC, this battery, for them, you may be burnt because of these high voltages or high currents. In case you're in parallel, where we shall need high currents, but in series they are high voltages. All parts we need protections. A protection, I mean, if this is our power bank, we are going to connect them on solar system. Please install the protection, the fuse protections, I mean the circuit breakers, okay? Use the circuit breakers. If this is our panel, this is our panel, this is the solar panel, okay? Now we want to connect it to our charge controller. Let us say this is our charge controller with positive, negative, and positive, negative for the rods. This is for the battery, this is for the panel, okay? Positive, negative, positive, negative. Charge controller has six terminals, and our panel has positive and negative, okay? Now this is our battery. Terminal is here. Now from the panel, I think this we need to do a full we need to see how we connect these things: a solar panel, a battery, regulator, and the inverter. I think in the next video we are going to study about connecting these solar panels, since we have covered solar panels, and to see, and we connect them with this charge controller. Then we see how we connect them with the batteries, okay? Let us see in the next video how we connect all this combination of solar panel, solar regulators, and the battery bank, plus the regulator, plus the inverter, okay? Before we go to inverters, okay? Now the protections, always use protections before you're using, because of the high currents. The protection is the circuit breakers. from the panel to the charge regulator, put a circuit breaker. A circuit breaker, positive, negative, okay, on and off. Then it goes to the charge controller. This is the charge controller. Then from the charge controller, it goes to the battery. Also here, you can put a circuit breaker, which you can switch on, off, when you want to do some wiring or you want to handle some wire exchange around the batteries. You can switch off these circuit breakers which are coming from the regulator, or you can switch off the panel. Always switch off the panel before you do any wiring or any changes, either on the regulator or on the power bank in parallel, though in series. Switch off the solar panel. Always switch off where the source is coming or where the source is bringing. It's like in electrical, when you're doing some electrical in your ceiling or in anywhere in the house, always you go to the main meter and you first switch off that circuit breaker, the main circuit breaker from the supply pole before you handle the repair part in the house. The same thing, go and switch off the circuit breaker. We are going to see how we wire all the system, the solar panel, the regulator, then the batteries. And we put those protective devices, okay, which are called the fuses. Use always the fuse or circuit breaker when you're dealing with solar batteries. And let us see how we can have, let us see the tips for handling solar panels in parallel or in the installation in solar. What are the tips you need to have? The gears, what you need to use, okay? Don't just go like this, the way you see me, and you just go. You enter, you start working on the solar system. Your life will be in danger. Let us see the tips which can help you when you're handling solar system. We are soon ending solar batteries, okay? And solar system, we are about to end it. We shall end with the inverter. The inverter changes DC. We are entering into AC. That's where we shall be going in general electricals. Okay. Now let us see some tips before you start working on solar system. You need to have this in mind before you start anything for your life safety. Okay. Let us jump and see which tips is needed when I'm going to handle a solar system or a solar batteries. This is a power bank. Now, should I go like this? Should I start working with it on a power bank like this? Let us see the tips, okay? Okay, now, since we have seen, now let us talk about the safety tips. Since we have seen what you need to avoid when you're handling the solar batteries, okay? Let us see. I'm giving you some safety tips before working on batteries. Safety tips before working on solar batteries, okay? The safety tips you need to know before working on solar batteries. One is wear eye protection. Wear eye protection. There are some glasses which are used when you're doing solar installations or when you're working on solar batteries. Wear eye protection, because these solar batteries, some batteries give out fumes, okay, and you may lose your eyes when you're working on high capacity or high voltage batteries. So always wear eye protection, okay, because you never know, the battery can burst and your eyes will be open. So when at least it finds when the eyes are protected, you will be saved. Okay. Now number 2 is remove metal jewelries. When you're dealing with battery connection, battery connection, this is parallel connection, always remove the metal, as our point, remove the metal jewelries. Metal jewelries, I mean if you have a chain, check this. If you have a chain, okay, don't work with chains, technicians. If you have this, which you wear in your hand, like this, please, don't work like this, or it is tied when you are putting it on, okay? Don't work with this metal jewelries. They don't allow it. Because if you're working with, now, I'm working with my jewelry, I'm working on a positive, this cable can tap inside here. While I'm going on the negative terminal, I make short, and I'm dealing in parallel, meaning I'm on high current, meaning my hand may be burnt. That's why it is advisable never to work with jewelries, never to work with any metal jewelries when you're dealing with battery banks. Always leave your hand free, like the way you see me. Leave your hand free when you're working with battery banks. Another point is use insulated tools. Use insulated tools. Insulated tools, I mean, when you're working with tools which are metallic, make sure they have insulation. Insulation is the rubber part which you touch, the rubber part. It will avoid some short circuits, or some electrical circuits. You may get some electric shocks, okay? That's why you need to use those insulated tools. Like screwdriver must be with a plastic or a rubber part, okay? Which one else? A plier, which is called magalo, or a plier, must be with a rubber part. Don't use a plain metallic that electric plier, okay? All electric tools must be with insulation. Another part is the never short, and this is so common. This is so common to people who are working in battery charging, okay? Some people have a business, you have solar panels, and you're doing your business, which is charging the batteries. Is a business to earn some income. You're charging batteries, but to test your batteries, you're doing what? You're short circuiting the terminals. And yet the one of the tips I'm giving you, never short either positive and negative, okay? These are terminals. Never short them. I don't know how I can explain this. You remember a battery has a positive terminal and a negative terminal. Then you put a wire. You want to test if the battery has capacity or there is some voltages. You short circuit the negative terminal and the positive terminal to see if there is sparks. That is a dangerous thing to short circuit these terminals. You remember this battery they have these electrodes. These electrodes are inside the battery. These electrodes have the electrolysis around it. Anytime the battery can burst, okay? The chemical reaction inside, you're shorting it. Why? For you're outside the battery, trying to make inside connection, getting stress. You never know, the battery can burst when you're there with it. Never do the testing of the battery. Whether you want to test the voltages, please, I told you, you must be having a meter, a multimeter, which has everything, current, voltages, resistance, okay? Use your multimeter to test for voltage on the battery. Don't short circuit the terminals. You will kill the battery. Inside, if you short circuit the battery, and you see some sparks, just inside the battery, you're killing the cells. Some cells are being short, okay? That's why you're seeing short on the cables, which you are short circuiting. Inside the battery, the cells are dying, okay? That's why in the long run, when you're testing, your battery, after some time, it will not function the efficiency we wanted. Okay? Now, it is not advisable to short circuit positive and negative terminal. This is an NB. As I've told you, if you're working on batteries, if you're working on power banks, please switch off the circuit breaker which is on the solar panel. This is our solar panel. This is the circuit breaker which it has two poles, positive pole and a negative pole. Switch off the circuit breaker. If you don't have a circuit breaker, please go on a regulator and untie, okay, or unscrew the positive, the negative terminal of the panel and the positive. Okay, please first remove, disconnect. But the best way is to install your circuit breaker. When you're working on the solar batteries, please switch off where the source of power is coming. Okay, then you can work on doing your wiring. Okay, meaning this regulator will not having power to bring on the batteries, only you're working on the batteries. Then after finishing, you can go and switch off and switch on. Okay, so that the power comes to charge your battery. Always switch off whenever you're doing any wiring. Switch off the panel because it is the source of power for our solar. Okay, and thank you for this knowledge. I think you're getting something, you're getting some help or knowledge about solar installation. I know we have come up from far away from the panels, then from the charge controllers. Now we are on the batteries. We are ending the battery connection. We have seen the series connection of the battery, that if you connect in series, you increase the voltages and the capacity of the batteries remain constant. Now we have seen now that in parallel connection, we increase the capacity, which is the charge, the ampere hours, it is increased, and the voltages remain constant in parallel connection. Okay, and we have seen the tips to work on before handling solar batteries, and we have seen the reasons to avoid when you're handling solar batteries. Thank you for watching. Let me see you with next video. We are going to see how we connect the series parallel connection, and we see how this solar panel, how can we combine. So since we have seen the solar panels, the regulators and the battery, how can we combine we put them together to work. Okay, so on the regulator there is a part where the loads are connected. We are going to see how we wire our solar system. Okay, in the next video we shall see how to wire a solar system. The solar panel, we have calculated the solar panel. Now we have the solar regulator. We have calculated the power, the regulator. We have calculated also the batteries. Now we are going to combine our solar system. We do the wiring, and you will see a clear way of wiring the solar system, and you learn, put it in mind. Always watch the videos. If you don't understand the video or the message from the video, please return it and re-see or re-video it, and it will help you to see and to learn more about solar. Before we go, because we are going to another sections, I don't want to leave you behind in the solar systems, yet we are going in electricals. Okay, if you have any comment, any question about solar, if you have any solar system if you have some difficulties in solar system, please comment any solar problem, so that I come in and effectively I give you the answer, and we share how we can help each other. Wherever you are, comment or like for more solar knowledges. We are soon ending solar systems. Then we go in electricals. Electricals, we shall start with the generation of where electricity started. Okay? And after electricals, we shall go and see the electronics. People who want to repair phones or all electronic gadgets, you are welcome on this channel, The Physics Mindset. Handle the videos very well. Each video has value. Don't miss any video. Every day, watch a video and you will know or master technical, engineering, and technologies which are coming up. The AIs, what all. If you know the knowledge in electrical, the knowledge in solar, and the knowledge in electronics. You know, AI is more of electronics. There we shall see how we play around the ICs, how you can build an AI using the IC, how you can program a IC. IC is an integrated circuit. You can program it using 1 and 0. The language of the computer is 1 and 0, meaning on and off, or 0 and 1, meaning 0 and 1, or 1 and 0. That means on, off, or on, or off, on. That's the language of the computer. We shall see them in electronics. Okay, thank you. See you in the next video when you're seeing we are combining the solar components, the solar appliance. The solar components are the solar panel, regulator, and the batteries, and we light our house. Thank you for watching. See you in the next video.